Here in this study, I'm going to talk about how I use remote sensing to determine water footprint of landscaping area in Great Salt Lake Basin. I used Landsat 7 to create the map of the lake in 2000 and 2022. As you can see, the area of the lake has been decreasing, which makes a lot of problem. And the most important is that right now we have a lot of dust in in the air, which is makes a lot of problem, especially health problem for the people who lives around the lake. So we need to make some decision to allocate more water to the lake. We have different water sector in this basin: agriculture, urban area, which is including industry, domestic water use, landscaping, and environment, which is usually the least important sector in basins, also in this basin too. So we need to consider some strategy to make a balance between these sectors, which makes the least impact on each of them. And of course each of them needs their own strategy. Here the chart is show the portion of the water use for each sectors, which is, as you can see, agriculture use the most, and here we can see the domestic water use in gallons per day per person, and also the percent of the population growth. As you can see, Utah has been the one that used a lot of water, and also the population in this area have been increasing. We have different kind of landscaping. One of them that is looks so green because having a lot of grass area, and which is use a lot of water. And another one is xeriscaping, that we don't use grass in this area and usually use some of the crops that use less water. Based on the available water that we have it in each basin, we have to redesign or design our landscaping. Of course, right now the number of the people has been increasing, so we need more water in urban area and for as like domestic water use. And also because of the climate change, we have water less than past, so we need to adopted our landscaping to the way that use less water than have been used. To do that, first we need to know that how much or what is the area of the landscaping, and then to see how much water is used, and then we make our decision and like consider some policy for landscaping and urban area. So we used remote sensing to do the classification, and then also to extract the water use that we have in this area. So the area that we try to work on it was cities in Utah state. The reason is that we don't have landscaping in other area, so we just focus on cities, and especially here in this study, Logan. We use Landsat 8 with a special resolution of 3 meters, and NAIP, which is National Agriculture Imageried Program, with a special resolution of 1 meters, which has 4 bands RGB near infrared to the classification. And we have used the classifiers of random forest, CART, and SPM. And the methods has been evaluated using or the result using confusion matrix and overall accuracy. After detecting or classify the urban area, and then we using OpenET, which is a platform that has developed for the east part of the USA, to calculate the actual evapotranspiration using Landsat 8 with different kind of algorithms. So for this we have just developed a Python script that extracted the data based on point data. So we can just extract the central coordinate point of each pixel, and then try with using this Python script extracted the actual evapotranspiration, which is a we have posted the Python script in HydroShare, and then I will later explain more about the script. Results show that Landsat random forest was the most accurate for the Landsat data, but as you can see here, the yellow color shows a street, gray shows the building, and green area is shows with green color. As you can see how much is different between RGB images and the map that we get classified after classifying from the Landsat and RF. And the reason is that because Landsat 8 has like the special resolution of 3 meters, which is not enough for the or appropriate for classifying the urban area. And then we try to use NAIP to do that. Before that, we just calculate some different vegetation indicators like GCI, NDVI, EXG, and EVI. And you can see some of them makes a good contrast between objects. For example, here you can see different contrasts that are your different color that we have between grass area and trees, building, a street. NDVI also makes a good contrast between objects than compared to the rest of indicators. So we use different combination of the NAIP bands with the vegetation indicators to see which one has or is more accurate. A random forest with the input set of the near infrared, RGB, and EXG was the most accurate, and totally random forest for each of the combination of input set was the most accurate, as you can see here, compared to the other machine learning. And also here I show the confusion matrix for different input set, while our machine learning here is random forest. Here I try to show that each of the machine learning works for the classification, while our input set has near infrared, RGB, and GCI. As you can see, random forest was the most accurate one. And for the while the our machine learning is random forest, I try to show how different input set works for classification. As you can see, the combination of near infrared, RGB, and GCI shows the objects better than others. Then I extracted the central coordinate of the pixel. Here I show just for the 1 pixel, and to extract the data from OpenET, and it shows the amount of water that has been using in this area from 2022, and here shows the annual actual evapotranspiration. For the classification, we have developed 2 Python script, one for the NAIP and another for the Landsat 8, which are almost similar. So here I'm just going to talk about how we did for the NAIP. First we just created some base map, and then we try to introduce our area of interest. That here I just try to importing a shapefile of Logan City. Then I importing NAIP and try to find the date that has NAIP provided 4 bands, and then clipped the imagery based on area of interest, and then I show them on the map. Then I try to create training data set, which we have here 3 classes, so we have 3 kind of training data set, and for each of them here I introduce 3 polygon. Then I try to calculate vegetation indicators. GMAP package provide some function that calculate the vegetation indicators, but it doesn't work for NAIP. It works for Landsat 8, but it doesn't work for NAIP. So for the NAIP, I try to write the equation and calculate it, as you can see here. And then the point is that the data is created by some names, which doesn't make any sense, and so I try to using consider some names for them, and then using this function selected and rename to the name that is more appropriate. After that, I try to collect the features which have we defined for training, and then also consider some bands for as input for the machine learning. Here, as you can see, right now our imagery has all of the bands and also vegetation indicators that we have created. After that, so we just developed random forest, cart, and SVM to do the classification based on the training data set that we have provided, and also the bands that we have considered as input set. And then we try to evaluate the methods based on the overall accuracy confusion matrix, and because every machine learning some factors that need to be tuned, so then we try to write some comments to tune the machine learning. So like here for the random forest, we just changing the number of trees and to see for which of the number of trees it works better, and then after we founded the best one, then we changed the factors and rerun the model to have the most accurate maps of the classification. We did the same one for the Landsat 8, so but I'm just here explain how we did for the NAIP. So there is not a big difference between whatever we have done for the Landsat 8 too. Here is show the repository of GitHub that I have posted the Python script for the NAIP and Landsat, and here also is some information. You can here see the link of the YouTube, the video of this presentation, and here also is the link that shows that we have posted the Python script for calculating or extracting the water use from OpenET. For the Python script that we have developed for the OpenET, here you need to, after registering for the OpenET, you need to here provide your API key, and after just run them, just here you have to provide the name of the CSV file, which is in here including the central coordinate points of the pixels. After that, you have to select the starting date that you need, ending date. Do you need the interval data as a monthly, yearly, daily, and also the variable, which is here is ET, and the model that you wanted or algorithm that you are desired, the units that you wanted, and after that running them, it shows the data based on the points that you provided, and after that you can extract the data in a CSV form. So for this study, I suggest that consider the area also as another class. Finding the best input set, we can consider another vegetation indicators, and you can consider all of them as a input set, and different combination of them can be used to classify. So we can find it's good to try to find the best one that provide the most accurate map for us. Increase of number of the ground truth area or the training data set. Here I just consider 3 polygon for each class, so we can consider more than 3 to help the model to classify the area of interest better. Thank you so much for the time. Here is my email address. If you need any helps, I will be so happy to answer any question that you have regarding my work. And here also is my GitHub name that you can find it, the Python script that has developed for the classification. Thank you so much for the time.